Bismillahirrahmanirrahim. I'm going to give you first an overview of the chapter, okay? This chapter is about rational functions. The mistake I made last time, I called them hyperbolas. I said it must have been brain fried. You have not seen hyperbolas, and you will not see hyperbolas in Algebra 1. Okay, these are just called rational functions. Okay? Now, this chapter specifically has like 3 parts, okay? The first part is rational functions. Okay? And the last part here is solving rational equations. Okay? Which are pretty easy in general. Okay? The middle part is something called long division. Okay, now this sounds scary to people, but it's really not that hard. All of these subjects, all these topics are by themselves not very difficult, I think. Okay, so, but you just have to kind of get to know them. So in my mind, this chapter is not very difficult. Now previously, we talked about rational functions. And I had suggested to you that the parent rational function is what? 1 over x. Just like the parent quadratic function was this, the parent radical function was this, right? The parent quadratic function was this. And what was this? Parent exponential, for there are 2 parents there, right? So these are exponential functions, right? These are radical functions. And these were quadratic functions, right? And these are rational functions. Because if you recall from a definition of rational numbers were all those numbers that could be written as a fraction. Yeah? So these are functions that have fractions. Well, variables within fractions in the denominator, right? You follow? Okay. So previously we had explored this parent function, right? And then I had suggested to you that the parent function here, okay, looks like this. Right? Kind of like this. It's better to go like, can make them accurate like this, right? Okay? It has 2 arms like this. 2 branches, whatever you like to call it. Alright? And this is called a rational function. It's not called a hyperbola. Okay? So this is a rational function. Right? And then we studied some characteristics of this function the other day. I had suggested to you that this function has like 2 asymptotes. Okay? The vertical and the horizontal asymptote. Okay? And the asymptote is a line that the function approaches but never crosses. Never crosses. It meets. Okay, and the vertical asymptote is easy, and the horizontal asymptote is equally easy. That's the graph. The point where the 2 asymptotes meets is the pseudovertex. Do you understand? You follow? That's our pseudovertex terminology. Does that make sense? So then we graph this function. We had this. See? That's the function. That's a rational function. If you zoom out, see, it looks like it's approaching there, right? Right? But it's really never, ever, ever approaches there. Because if you go like this, right? Look at this. Does it seem like it's getting there? Yeah. So it never reaches there. Okay. So that's that. And then we played with this, right? We said if f of x is 1 over x, what does this look like? How was this? This was a mirror image of that, right? Where, okay, if this is the parent equation right here, so I'm going to draw the parent function. This would be the mirror image. In the mirror image, see, this side is going over here. It's mirror image across the x-axis. It's not going this the other way. Okay? Right? And we had also said, if this is the parent function, this was what? The whole parent function moved up 3 spaces. So that would be like the new asymptote. And this would be the new function. Okay? And then we said the general expression that represents this function, okay, you can write it like this. And that was it. It's pretty easy, right? It's a rational function. Now this is very similar to other functions that we had previously explored. Quadratic function and a radical function. Right? They all have the same pattern, see? A times x minus bx is somewhere over there, and vy is over here. In this case, it's in the denominator because that's the defining feature of the function. Here, that the same quantity gets a square because that's the defining feature of that function. Here, that quantity gets a radical sign because that's the defining feature of the function. Right? So, if you wanted to graph this, now let's explore some more before we actually do a couple examples of this. Okay, so if this is f of x, the parent function, okay, if this is the parent function, and what do you think this would be like? It would be, well, how would that change?
Go up faster. Go down.
Well, watch. See this point right here? If you put stuff over here, see, you're going to do one of two things. You're going to pull this point over this way, okay? Or you're going to pull it that way, okay? Okay. So when x is 1, it's 1 over here, right? In this new function, when x is 1, it is like over here, right? So it's going to be like this. You follow? Okay, so let me suggest. See the blue guy? Okay, now what would you think if I put 0.5 over this to 3? See? Do you understand? Okay, so the first one is called a stretch. The other shrink. Makes sense. Stretch and shrink. Easy enough, right? Okay, we explored that. Alright, If you put a negative 3, it's going to do the stretch, it's going to flip. Right? And if you put plus 3 in the back, it's going to stretch, flip, plus 3. And put something in the bottom, right next to it, you have stretch, flip, right, up. It's kind of like that. Yeah? So it's not that bad, right? So, having said this, let's do this. Okay, what do you think about this? Okay, who wants to do this? Okay. All right, let's do it.
The asymptotes, the 3 and 2.
Yeah, so what you first want to do, find like the pseudovertex, right?
Oh, yeah.
So that's the Vx and the Vy, right? And that's going to be what?
3 and 2.
3 and 2, very good. So these are the new asymptotes, right? X is going to be equal to 3, y is going to equal to
3, 2,
2, right? Agree?
Yeah.
It's as easy as that. Now, see, this number doesn't affect the asymptotes. What does that number do anyways?
It stretches.
Yes, it's going to stretch it. And it's going to flip it. Okay, but let's draw our asymptotes. Everybody agree? Okay.
Isn't 3 supposed to be x? So it would go
1, 2, 3. Yes?
yeah. Isn't it supposed to be flipped because x is
I'm not drawing the graph yet. I'm just drawing the asymptotes. The graph is going to be somewhere in these 4 quadrants, right? Okay. Which quadrants is it going to be in?
Here in that quadrant.
Who?
The top 3. Fourth. Oh, yeah. The second one and the fourth.
That's very good. So it's going to be a mirror image, right?
Yeah.
So instead of being here and here, it's going to be here and here. Okay. So it's going to look kind of like this, right?
Yeah.
Okay. Now, is it going to be a stretched or shrunk?
Stretched.
Yes. So let's say if this was the parent graph, see the parent graph is like 1, 1 over here, right? 1 unit, right? You follow what I'm saying? So parent graph is like 1 unit long, like a nice square wheel. So this would be the parent graph right here. Okay? If that was the parent graph, this one is going to be kind of like, I don't know where it's going to be. It's going to be like this. You follow? Right? So it's going to be like this, approximately. Now what you would do is, okay, you can't do approximately. So you need to get like 3 points here, okay? You got to get 1 point here, 1 point here, 1 point here, graph. Got it? And 1 point here, 1 point here, 1 point here, and graph. Let's just do this for the sake of graphing, okay? I'm going to do this one first, okay? You have to pick 3 points. So what 3 points are you going to pick? Let me do it over here. Okay, we need 3 points, okay? What are you going to pick?
Oh,
3 points to graph this part.
5.
5, very good. 10.
100.
No. Okay. You got to make your math easy. So this is x equals 3, right? Right here's 3, right?
Yeah.
Okay. Okay, you want me to plug it in with, how about 4? Right? Okay, how about 5? Okay, let's see what happens when you do that. If you plug in f of 4, okay, you get negative 2 over 1 plus 2, right? Yes? You do it. I'm not going to do it. Okay, plug in 4. What'd you get? You're plugging 4 over here, right? Who? Hmm?
I don't get it.
No, no. So what's the value of the function? You're trying to find some points on the function, right?
Yeah.
So what's the value of the function when x is 4 is what I want to know. How do you figure that out?
You plug it in for negative 2 over 4 minus 3 plus.
That's what I just said. Okay, 4, okay, good.
Oh.
Plus?
Plus 2.
Okay. Then?
And then that equals negative 2 over 1. Oh, plus 2.
And?
And then that equals
What am I doing too fast for you? Okay. Then?
0.
Yeah, okay, very good. So I have 1 point right there. Okay, that's 4. Okay. How about 5? What happens if I plug in 5, right? Okay, what do I get? Let's go for it.
Negative 2
Oh, it's going fast now. Okay.
plus 2.
And?
That equals 1.
Oh, that's 1. So 0, 1. Okay, so I got 1 point over here. So I got 1 point over here. And I got 1 point, when it's 5, it's like 1. Okay, I kind of need a point over here, right? So we're going to have to like 3.5 or something like that. Okay? If we do 3.5, okay, so let's just do f of 3.5. Then negative 2 over, you can do calculate if you don't know. Okay, 3.5 minus 3 is 0.5. Okay, plus 2. Okay? So negative 2 divided by 0.5 is 4. Okay, it's negative 4 plus 2. So, and that is negative 2. So you do that and you get like over here. Okay? Ta-da! Do you understand? So now you have these 3 points. Do you get it? Okay. Now to draw this one, okay, you have to make a you have to come up with some points. So you need a point here, 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 right? So this is 3, so you're gonna pick, I don't know. What would you pick? If you want to graph this arm. Amma, what would you pick? Okay, well, if you pick 3, you get negative 2 divided by 3 minus 3 plus 2, right? So that's like negative 2 over 0 plus 2. And then your calculator explodes. Right? Because why? That's undefined. That's why it's an asymptote. 3 is the asymptote. Do you follow? It doesn't work. 3 does not work. It's okay. Good try though. I'll give you 100 points for intention. Okay. Now what?
6.
Oh, that'll give you over here. You want to graph this dude over here. So you want points over here.
What, 2?
Ah, 2 is a good one. Okay. So let's do 2. Okay, so f of 2 is going to be negative 2 over, you tell me,
Negative 1
negative 1
plus 2.
plus 2. And this is
That's half, or
negative 2 divided by negative 1?
1.5.
It's 2, last time I checked.
Oh,
Okay, 2 plus 2 is?
4.
Last time I checked. When it's 2, it's 4. So when it's 2, it is up here. Okay. Now what? You need more points, right?
Yeah.
Okay, what do you want to do?
1.
Okay, very good. F of 1. So that's what?
Negative 2 over 1. Negative 2.
1 minus 2. Yeah, that's
1 minus 3.
is negative 2 plus
2.
2. Okay. That's what?
1.
So this is 1 plus 2.
That's 3.
Okay, that's 3. So when it's 1, it is?
3.
Okay, so that's right there. How about one more?
0.
Okay, you can do 0. So f of 0 is?
Negative 2 over negative 3
Uh-huh.
plus 2.
Plus 2. This is 2/3. 2 and 2/3, right? 2 and 2/3. So then 0, it is 2 and 2/3 right there. Do you understand?
Yeah.
So here's the graph. So that's what you would have to do. You have to pick some points to make your graph kind of reasonably. Does that make sense? Okay. Yes.
So the pseudo vertex that the graph gives, it doesn't give anything on the graph, it just gives the asymptote, and then you have to find your own.
There we go. See that? Okay, so I'm going to graph the asymptotes now. X equals to 2. And then we have y equals to 3. See? Got it? Now, I'm going to graph another graph over here. It will be the parent function without this 2, okay? So it's good, because I want to show you this. Negative 2 divided by x minus 2, okay? Plus 3. These two are the same functions, okay? I'm just going to get rid of the 2 and make it into a 1. You see? The 2 stretched it, right? This is the parent, will be the parent function. It made it go that way. Yeah? Do you understand? Okay. So far so good? Abdullah, what do you think? You got it? Okay, so here's what you gotta know. So what is this? This is the vertex form of? Vertex form of a quadratic. Okay? What is this? This is just a radical function. Okay? And what is this? This is a rational function. Okay? So, how about this? Let's just do this. Okay, and then we'll go on. Okay? Inshallah. Until next time.